In this lecture, we're going to set up constant iterators for our box container class. And now you must be asking, why would you need constant iterators? Let's look at a simple example. Here we have a box container. It is an innocently looking box container object, vi. It has some data n, and we are using vi to set up another copy of the data using our copy constructor. We already have a copy constructor for a box container, so this is going to work. But notice that this copy is going to be const. And if we try to print it out using the code here, please take a moment. This is going to work. So we are going to be looping. We are going to be looping as long as it is not equal to the end iterator, and we're going to keep incrementing. And at each iteration, we're going to dereference the iterator and print whatever element we are at. But the problem is going to be that the iterators provided by our box container class now are not constant iterators, and they can be used to modify the collection, but the collection is constant in the first place. And the compiler is not going to allow us to use iterators that could be used to modify the collection. And if you try to compile code like this, you're going to get a bunch of compiler errors. So this is one reason we need constant iterators. If we provide constant iterators, they are going to be picked up by the compiler if we set up code like this working on a constant container. Another good example is that we may have a function like this that takes a parameter by const reference. Again, because this is a const parameter, we are not allowed to use non-constant iterators to iterate through this. And as you already know, the range-based for loop here is going to generate a bunch of iterators. It's going to use behind the scenes. And those iterators are going to be using the begin and end methods we have in our box container. And those methods, as they are now, they provide non-constant iterators that can't work on a constant object that we have in our parameter list here. So again, this is going to throw a compiler error. To make this work, we need to make box container provide constant iterators that can work in these two scenarios. And to provide a constant iterator is really not a difficult thing. So what we need to do, we're going to provide another class that's going to be const iterator, as you see here. It is going to provide the needed type aliases, as you see here, but we are going to make sure that our pointer type and reference type are const. Because this is a const iterator, we can't allow people to go through what we return through pointer type or reference type to modify the data in our collection here. Once we have this, we're going to provide a bunch of operators that are needed. These are going to be exactly the same like we had before with our iterator class. We are going to provide our begin and end method as we did before. They are going to return iterator. We are going to provide cBegin and cEnd. These are going to be called when we need constant iterators. And they are going to return the same thing, but they are going to be using constant iterator here. Another thing we need to do to make our code work is to provide constant overload for the begin and end methods. These are going to return constant iterators if people happen to use our begin and end methods on a constant iterator. These are going to be picked up by the compiler and your code is going to work. Once we have these in, the code here is going to work, and the code here is going to work because we have proper iterators in place to make this work. I know this may be cryptic right now, but we're just going to head over to Visual Studio Code and play with us a little more. Hopefully it is going to make sense. Here we are in our working folder. The current project is Constant Iterators. We're going to grab the code from the last lecture. I think this is going to be a good starting point. And we're going to put that in the current project. And we're going to crack this open in Visual Studio Code like we always do. Let's wait for this to come up. We're going to have our class here. This is the main CPP file. I think we can clean this up, the main function. We're going to put in a completely new code here. So let's make sure we clean up everything. And we have a clean main function. We are also going to take out whatever gibberish we have on top here. And we're just going to leave in a print function, which is going to print our box container of things. Now, we are going to go in the main CPP file, or the main function, I should say, and set up our box container. We're going to put in data. And we are going to create a copy of this thing. Let's comment out everything we have on top here to make sure that you know that the problem is coming from the code we have right here. So if we create our copy and build with one of the compilers, I am going to use GCC because it is my favorite. You're going to see that the build is good, and this is working because we have a copy constructor. If we go in box container, I think we're going to find that right here. Let's make sure we see our copy constructor. Where is it? It is right here. So this is going to be used to set up the copy we have here. But the problem is going to come if we try to print this using this loop here. Again, notice that this is a const container. If we take out this const, you're going to see that this is going to work. You see, the code has no problem. And if we build, we're going to use GCC, the build is going to be good. But if we make this const, it is going to become a box container we can't modify. And the begin and end iterators are providing iterators we can go through to modify this to const box container. So if we kind of want this code here to work, we have no choice but to provide our own constant iterators. Another thing I want you to see is that our code in the print function is also not going to work. For example, if we say print and pass in our copy, let's go down here and say that we're going to say print and we're going to say copy. We're going to pass our copy that we want to be printed here. You're going to see that this is also not going to work. This is going to throw a bunch of compiler errors because we could use iterators used by this range-based for loop to modify the underlying data. So again, to make this work, we need to provide constant iterators for our box container class. Let's go back to our class and do that. We can go below our iterator class. We have that right here, and we can go right below it and provide our constant iterator class. I am just going to put that in here, and I am going to explain it bit by bit, whatever I need to explain. So let's paste that in here. And if we go to the top again, we're going to find our class for constant iterator. We have to make sure it is aligned with the rest of the code. It is just a class which is going to provide these type aliases that are needed by the C++ standard library. We have to make sure pointer type and reference type are const because this is a const iterator. We don't want people to go through this pointer or this reference to modify the underlying data. And the rest is really going to be the same. We're going to just copy what we had in our iterator and provide a default constructor, a constructor which is going to take a pointer, and we have all kinds of crazy operators here to make this work as a random access iterator. Once we have this, we have to provide const overloads for the begin and end method. So we are going to say begin and end here, and we're just going to return const iterator. So let's say const iterator here. We're going to say const iterator here. And we're just going to be building const iterators in our bodies here. Let's take this out. I don't know what I copied. So let's copy and say const iterator here. And we're going to say const iterator. And these are going to be const because they are not allowed to modify our collection. But we also need to provide the cBegin and cEnd methods. And we're going to put them right here. And they are going to do exactly what we expect here. They are just going to say cBegin and cEnd, and they are going to return constant iterators because that's what they are. Now, if we go back to our main function and try to build again, we are trying to use the print function here. Let's pass this through the compiler. We're going to use GCC. Now you should see that the build is good because we have the needed iterators, or to be specific, constant iterators for this to work. So we are going to run this. Let's bring up a terminal window. We can bring this up a little bit. If we clear and run rooster, this is going to print our collection. Nothing special here. And we can use the code we had before. That didn't work. But now it's going to work because our constant iterator is going to be picked up whenever we call begin on a constant container. So what the compiler is going to see, it's going to see that this container is const. It's going to see that we are calling a begin method, and the compiler is going to ask, isn't there a begin method I can call to give me a constant iterator that can be used to modify my underlying container? And it is going to find our const overloads here, and the things are going to fall in place. Let's say that this is going to give us const iterators. And now if we build the code, everything is going to just fall in place. Let's pass this through GCC. The build is going to be good. We can clear and run Rooster, and this is going to work. This is really all I had to share in this lecture, showing you how you can set up constant iterators for your collection. And we also had a chance to explore why we might need these constant iterators in the first place. Again, we have two reasons here. The first is that we may need our iterators to work for const containers, but we may also need that to work if we are passing constant containers as parameters to functions, and this is going to work if we have constant iterators in place. We are going to stop here in this lecture. In the next one, I am going to show you that we can use row pointers as iterators if we happen to need that in our C++ program. Go ahead and finish up here and meet me there.